Today we'll be looking at the cross product of two vectors. So to begin, the cross product is used to determine a vector that is perpendicular to two non-zero, non-collinear vectors. It will be used to determine the area of a parallelogram and solve questions involving torque, which will be seen in 7.7 applications of the dot and cross product. So in our first example here, given our two vectors, A and B, A is 1, 1, 0 and B is 1, 3, negative 1, we want to determine the cross product between the two. So what are we looking for? We're looking for some vector V that is perpendicular to A and B. So we're going to let V be our X, Y, and Z. So since we are looking for something that is perpendicular, what we know, we know therefore that the vector A times our vector V will be equal to 0, and our vector B, the dot product between the two will be equal to 0. We know that will be true if perpendicular. So what we're going to do here is look at this where we do the dot product between 1, 1, 0 and our vector V, X, Y, Z, which is equal to 0, and the dot product between B and V, so 1, 3, negative 1, and our vector V, X, Y, Z, which is equal to 0. So therefore, when doing the dot product here with our A and our V, we have X plus Y is equal to 0. And when we're doing B and V, we have X plus So, as you noticed, that was a lot of work in example 1. So it would be awesome if there was a great way to use a cross product, some sort of formula. So you can develop a formula by following the procedure we did in example 1 with general vectors A, B, and U. So in the text you'll be able to read that proof. However, the formula for calculating the cross product of algebraic vectors is as such. Given any two non-zero collinear vectors A and B, a perpendicular vector K times A2 B3 minus A3 B2 A3 B1 minus A1 B3 A1 B2 minus A2 B1 can be found, where K is always an element of the real numbers. So if K were to be equal to 1, then the cross product between our A and B is as such. And if K were to be negative 1, then the cross product between B and A would be as such. So that's nice and dandy, but really, how do we use this? So let's go ahead and look at a couple of examples. So what we're going to do here, given our vectors A and B, we want to determine the cross product between A and B using our formula, and then we will continue looking at further examples. So we're going to do the cross product between our A and B. So remember, when we're doing the cross product, here we have our A2, which is 1, times our A3, which is negative 1. So we have negative 1 minus, then we minus A3, which is negative 1, times our B2. Sorry, A3 is 0 and our B2 is 3, so it's minus 0. Our next one there, we do A3, which is 0 times B1, which is 1, so we have 0 minus, then A1, so 1, times our B3, negative 1, so minus negative 1. And then we have our A1, so 1, times our B2, so 3, minus our A2, which is 1, times our B1, which is 1, so minus 1. So what we can do there is we can collect those, and what we get is negative 1, 1, 2. Now, another useful way to remember doing the cross product, what we can do here is we can set this up and we can write out our values. So what I mean by writing out our values is writing out our vector A. However, since our formula starts with A2, what we're going to start with is we're going to start right at the second one, so our middle one here. So what we'll have is 1, 0, 1, 1, and then what you're going to have is we start again at B2, so 3, negative 1, 1, 3. And then what we do is we use the cross product. So remember, it's A2 times B3, subtract our A3 times our B2, and then we continue. And the second one here is our A3 times our B1, so 0 times 1, and then our A1 times our B3, so 1 times negative 1. And then our last one here is A1 times our B2, and then our A2 times our B1. So we can use that as well when using the cross product. So let's look at our next example here. So when we're looking at our next example, what we have is our vectors A and B. So negative 5, 0, 3 for A, and B is 7, negative 2, 3. So starting at our 0, or what you could really do is you could write out the vector twice. So I can show it that way as well. So negative 5, 0, 3, negative 5, 0, 3, 7, negative 2, 3, 7, negative 2, 3. However, I want you to cross it out, the top and the bottom, because we won't be using those. So next what we can do is we can follow and do the cross product. So what we'll have here is 0 times 3, so the cross product between A and B. 0 times 3 is 0, and then we are going to minus 3 times negative 2, so negative 6, so it's really plus 6. Then 3 times 7, so 21, minus negative 5 times 3, so plus 15. And then negative 5 times negative 2, so 10, minus 0 times 7, so minus 0. So what we have there for our cross product is 6, 36, 10. Now one thing it asks us to do is to actually find the cross product between the two to see what it equals, because if it equals 0 then we know that it's perpendicular. So the cross product between this are 6, 36, and 10, and our vector A, so it doesn't matter which vector that you take here. So this is how we verify our answer. So this will be equal 6 times negative 5 is going to be negative 30, plus 36 times 0 is just 0, and 10 times 3 is plus 30. Therefore, it's equal 0, so therefore perpendicular. And we know therefore we have done the question correct. Now looking at this investigation here, it gives us two vectors A and B, and we want to calculate A cross B and cross product, and the cross product between B and A. And what we want to do here is we want to know what property are you trying to demonstrate here. So, and how are the vectors A and B and A related? And write an expression that relates A cross B and B cross A. So what we're going to do here is we're going to look at the cross product between the two vectors first. So, looking at our A cross B here, so we can write this out. So 2, 4, 6, 2, 4, 6, negative 1, 2, negative 5, negative 1, 2, negative 5. Cross out the top, cross out the bottom, and we can get going here. 4 times negative 5, negative 20, minus 12, negative 6, minus negative 10, so that's actually plus 10. And then we have 4, and then minus negative 4, so plus 4, which is equal to negative 32, 4, and 8. So here we have our k value, which is equal to 1. And next what we can do is we can look at our cross product between B and A. So here we're going to write our B first, so 1, 2, negative 5, negative 1, 2, negative 5, so the first one should have been negative, and 2, 4, 6, 2, 4, 6, cross out the top, cross out the bottom, and we can get going here. So we have 12 minus negative 20, so that's plus 20, and then we have negative 10 minus negative 6, so that's plus 6, and then negative 4 minus 4. So this is equal to 32, negative 4, and negative 8. So therefore our k is equal to negative 1, and therefore we know this is not commutative. And will the expression you wrote in part A be true for any pair of vectors in R3? So I'm going to explain this. So if either is the 0 vector or they are parallel, the cross product is 0. Now in part C, using our two vectors given in part A and the third vector C, we want to calculate the cross product between A and B plus C. So what we need to do first is find B plus C. So B plus C, remember from before, B was equal to negative 1, 2, and negative 5. So we just add our negative 1 plus 4 and 2 plus 3 and negative 5 plus negative 1. So that will be equal to 3, 5, negative 6. So now we do the cross product between the two. So we can write out our vector A. So 2, 4, 6, 2, 4, 6. And then our vector B plus C. So 3, 5, negative 6, 3, 5, negative 6. Cross out the top, cross out the bottom. So we have negative 24 minus 30. And then 18 minus negative 12, so plus 12. And then we have 10 minus, oops, sorry, that was supposed to be 12, so minus 12 there, which when we add those up, negative 54, 30, negative 2. Now I want you guys to try doing the second part of C on your own, and then compare the two and think about what property we have looked at here. So now in part E here, you want to choose any vector that is collinear with A. That is, any vector of the form of our scalar k times our vector A, where k is an element of the real numbers, and calculate our cross product between A and Ka. And what can we conclude here? So remember, our vector A is 2, 4, 6. And then looking at our Ka, so let's choose 2 for K, times our 2, 4, 6. So this would be equal to 4, 8, 12. So now let's look at the cross product between the two. So we have 2, 4, 6, 2, 4, 6, and 4, 8, 12, 4, 8, 12. And what we can do here, cross out the top and cross out the bottom. So next step is to actually perform the cross product. So what we have here is 4 times 12, which is 48, minus our 8 times 6, which is 48, and then 6 times 4, which is 24, minus 2 times 12, which is 24, 2 times 8, 16, minus 4 times 4, which is 16. So therefore it's equal to 0, 0, 0. So therefore we know they are parallel vectors, since the cross product between the two is the 0 vector. So now let's just look at a couple properties of the cross product. So P, Q, and R are three vectors in R3, where K is an element of the real numbers. So we have vector multiplication, where the vectors, when you do the cross product between P and Q, is just equal to the negative cross product between Q and P. So just the opposite, but negative. The distributive law of vector multiplication, if we're doing the cross product between P and Q plus R, that's the same as having the cross product between P and Q and adding it to the cross product between P and R. And then our scalar multiplication here, if we're multiplying K by our cross product of P and Q, that's equal to K times our vector P and then the cross product between Q, or the cross product between P and KQ. So note here, the vector A cross B is a vector that is perpendicular to both the vectors A and B. An infinite number of vectors satisfy this condition, all of which are scalar multiples of each other. Now, the cross product only exists in R3, and it is not possible to take two non-collinear vectors in R2 and construct a third vector perpendicular to the two vectors, because the vector would be outside the given plane. Now for example 3, it wants you to look at the vectors in R3 and discuss each calculation. So I would like you to do this on your own and discuss it with your partner tomorrow.